Hello and welcome to today's lesson. We're going to be talking about topics under the lesson samples. So what this means is we're going to be looking at whether or not a sample is random or non-random, whether or not that a sample has been taken correctly, and whether that sample was biased or unbiased, and whether or not that led to valid or invalid results. So we're going to be taking a lot of notes on which characteristics a sample has to be to fit those different descriptions. So you want to make sure that you have those copied down so that it helps you remember it by taking the action of writing, but you also have them to reference when you are trying these problems on your own and studying. If I ever go too fast, just pause the video, write down what you need to write down, and then unpause and get caught back up. You can even pause at the beginning of the question. You decide what you think the correct answer is, and then watch the video to see if you got it right or wrong and if my explanation lines up with what you were thinking. And that can give you a gauge on what areas you need to study and what areas you still really need to, or you really know already. So I'm so glad that you are joining us today, and let's go ahead and take some notes.
First, we need to understand what a sample is. And so a sample is a group of person or elements selected from the total population. And so to understand that definition, you need to know that a population is an entire group of persons or elements that have at least one thing in common. So Minnesota fourth graders, Moorhead State University summer school students, those are a population. And when you just pick a few of them out of there to survey or ask questions to, that's choosing a sample. And you have to choose a sample well to get accurate results. And so the larger your sample is, the more accurate your results are. And a completely random sample of the population also you are interested in also leads to more accurate results. And so here's an example of the difference between population and sample in a picture form. And so if you're looking at ants for some reason, picking 9 of those ants randomly would be a sample. And so what it looks like for that sample to be random, and that means a good sample without bias, is that everybody has an equal and independent chance to be part of it. It selects a complete representation of the population. It should be large and random, and it shouldn't have any bias. Whereas if it's not random, the opposite of that is they are chosen based on a criteria. There is no equal chance. Some will have no chance at all, and there will be some type of bias, just to help you to differentiate between what is a random and a non-random sample. The following questions are also going to ask you if the sample is biased or not. So we need to understand what sampling bias is, and it's caused by systematic errors in the sampling process. So for an example, take 1/4 of the students in a class as a sample to use in a research study. You send out notes to the parents requesting permission for the child to participate in the study, and then select those students whose parents gave permission first as the sample of the study. And so you might have had the parents that work nights might not have got that signed right away, and so you're totally eliminating those students from your sample. So it needs to be completely random. And so here is a visualization of sampling bias. So you have this total population here, but for your sample, you only pick kids whose favorite colors are orange and blue. And so that's not a good sample. It's not representative of the entire population. Which of the following is an example of a random sample? So all of those notes that you just took, and if I went too fast, go back and rewind and make sure you get them copied down. Okay, let's look at which one of these, using that information, let's look at which one of these is an example of a random sample. So A, 10 members of the student council answer questions about the administration. So if you're trying to find out information about the administration, this isn't a very good sample because you're only asking people who work with them as part of the student council. So this one is not random. B, the 100 students out of 2,000 at a middle school are chosen randomly is a good word, to complete an anonymous survey. So here, the fact that it was random and anonymous, those are two really great things that lead to a random sample. And so that's probably going to be my answer, but let's go ahead and check the rest. C says the school cheerleaders are asked to their opinion about the football team. So if you're trying to find out about the football team, only asking the cheerleaders that cheer for them is not a very good sample. They're probably going to have different opinions than other people. So C isn't a good answer. And then D, a band director asked the 7 section leaders to fill out a survey about their favorite halftime music. So if he's trying to find out everyone's favorite halftime music, only asking the section leaders, people who have earned that position because they really like music and really like band, that's not going to be a good representation of what everyone's favorite music is. So it's not very random. So it's not going to be D. So that means B is going to be my final answer. This question says an advertising company wants to determine which cereal had the highest sales in Ohio. Which one of the following would be the most appropriate sampling technique? So let's make sure we read through all of the answers. So A, a survey of every 100th customer starting from a random position within the first 100 customers who bought cereal at any 50 different grocery stores throughout Ohio over a 1-week period. So that seems pretty random. They did 100 customers and they just randomized where they started, and they randomized and they pulled from a bunch of different grocery stores. The only thing is they only did it for over a 1-week period, and so some people might not have gone grocery shopping that week, and so that might not be the best. But let's look at the rest of the answers. And so a survey of 100 customers starting from a random position within the first 100 customers at any 50 different grocery stores throughout Ohio over a 2-month period. So the only difference here is the fact that this one was over a 2-month period. So you're finding out, you're getting a bigger sample of different people. So not just people who shop on the first day of the week or on the first week of the month. And so this B is better than A. So we're going to leave B and see about C. So a survey of 100 customers starting from a random position within the first 100 customers who bought cereal at any 50 different grocery stores throughout Ohio over a 2-month period. The difference between B and C is people who bought cereal, and B doesn't have that part. And so if you're trying to decide which cereal had the highest sales, you only want to talk to people who bought cereal. So it's not going to be B. So far, C is my best choice. And so let's go ahead and see what D said. A survey of 100 customers starting from a random position within the first 100 customers who bought cereal at any 50 different grocery stores in eastern Ohio over a 2-month period. So the only difference between C and D is D says eastern Ohio. They're looking for sales in all of Ohio. So you don't want to eliminate asking people in western Ohio because that could give you bad results. So it's not going to be D, so that means C is going to be my final answer. It's very important to pay close attention to those very small changes between each answer to be successful at these. Number 4 says, a toy bin has 20 toys in it, 5 of each type. So there's 4 different types. Storm wants to know which type of toy he would pick if he pulled one out. Which of the following would be the most appropriate sampling technique? So once again, we need to go through each choice. So A, he could make a chart to show all of the toys that other people pulled out. B, he could use a random number generator with total number of toys as the top number. C, he could use a spinner with 5 equal size sections, 1 for each toy. Well, C, right away I can see that the problem there is that there isn't 5 different toys. there's 4 different toys and 5 of each of those types, and that's how they get the 20. So it's not going to be C. And then D, he could use a spinner with 4 equal size sections, 1 for each toy. Well, going back to B here, B, a random generator with the total number of toys as the top number. Well, total number of toys is 20, and so 1 out of 20, that's not really helping him to choose which kind of toy he would got because there's duplicate toys in there. If they were all different, B would be good, but because there's duplicate toys in there, we don't want to use B. And A, you could do A, however, with experimental probability, you have to have very large numbers for it to be accurate, whereas when you use a spinner, you're giving each piece an equal turn, an equal chance. And when you give it equal chance, that's the best choice. So that's going to make D the final answer. This next question says, Sharon wants to find out the percentage of households that have internet access across the United States. She randomly calls 10 households and finds out that 6 of them have internet access. She concludes that 60% of the households in the United States have internet access. Which of the following is the best way for Sharon to get an accurate statistic? A, make sure that the 10 households you surveyed were selected randomly. Well, that's good, but let's go through all the answers so we can find the best answer. B, make sure the 10 households you survey lived in the same area. Well, if you're going for across the United States, you want them to be randomly from all over the United States, so B is not a good option. C, use a larger sample of households. Yeah. Calling more people is better than making sure that just 10 of them were selected randomly. So because this is such a small number and C is a larger sample, that's why C is better than A. And then D, double check the results by calling the 10 households back that were surveyed. So getting that larger sample is going to do more good than calling them back. And hopefully you're keeping accurate results since it's just a yes or no question. So C is going to be your final answer. This next question says, a dog biscuit company wants to know which size treat is preferred among dog owners. The company set up a booth at the small dog competition where they handed out samples of their biscuits. The participants who took samples were asked to complete a survey. Would this be an appropriate sampling technique for the dog biscuit company to use? So yes or no? So no, because the small breed owners at the small dog competition would have all small dogs. Well, that's a legit fear. If you are looking at all dog owners, it doesn't specifically say small dog owners, then you need to ask dog owners that have small, medium, large dogs of all sizes to get an accurate. So it could be A. Let's look at B. Yes, because this is a good sample owners with all sizes of dogs. It's not all sizes of dogs. It's only small, so it can't be B. No, because some people may not want to fill out the survey. Well, you can't help that, but you can help asking dogs of all sizes, so it's not going to be C. Yes, because the sample is random. However, it's not random because you're just asking small dogs and not dogs of all sizes, so it's not going to be D. So that means A is going to be your final answer. So this question says, Mr. Jameson is a math teacher at Richland High School. He is curious about how many students at his high school enjoy math. To find out, he gives surveys to all the students in his advanced math classes. Which of the following statements is correct? And so if I look at my answers here, it wants to know if it's biased or unbiased or both or neither. Well, it has to be one or the other. It can't be both. It can't be neither. So it's either going to be A or D. Now, if you look, he asked only students that are in the advanced math classes if they liked math. So that's not a very good sample because there could be some, if they're in those advanced math classes, they probably do well at math. There's some bias there. So this method of sampling is biased, which is choice C. This question says the circus came to town for the first time and the managers wanted to get an idea of how many people attending the opening night performance would recommend the circus to their friends and family. They decided to randomly survey people as they left. Which of the following correctly describes this method of sampling? So once again, they want to know, is this method of sampling biased, unbiased, both, or neither? Well, once again, it's either one or the other, so it can't be B or D. And so since their population is the people who attended, randomly asking people as they left is a good way to get a sample. So this is a unbiased method of sampling, so my final answer here is going to be C. Number 9 says Susie wants to determine the percentage of people in the United States that have a college degree. She conducts an email survey of 150 people, selecting 3 people from each state. 75 of the people surveyed have a college degree. Based on the survey, Susie concluded that 50% of the people in the United States have a college degree. So this question, if I look at the answers, is wanting to know if her conclusion is valid or not valid. Because it was a random sample or a biased sample. So she's looking at the people in the United States. So if she randomly emails 3 people from each state, that's a good random way, so that she's ensuring that she gets a little bit of everybody from each state and not leaving any state out. And then she picks those people randomly. So that's a good random sample. So that means her conclusion is going to be valid, which is A. This example says Golf Federation wants to find out which brand of golf balls are the most popular among men living in the United States between the ages of 25 and 40. They surveyed 100 of their male customers living in California between the ages of 25 and 40. The Golf Federation found that the most popular golf ball is Miller, followed by Smith & Sixon. Therefore, the Golf Federation concludes that the most popular brand of golf balls among men living in the United States between the ages of 25 and 40 is Miller. Which of this statement is true about Golf Federation's conclusion? So once again, we're looking to see if it was valid or not valid, and whether or not that sample was biased or random in these answers. So they're wanting to look at men living in the entire United States between ages of 25 and 40. That's their population. However, they just surveyed males living in California. So they left out all the other 49 states, even though they said they wanted to look at the entire United States. So since the sample was not random, the results aren't going to be valid. So A says that they are valid, so it can't be A. And it can't be C for the same reason. They both say was valid. So it's either going to be B or D. And so we need to look at the reasons on why B and D say not valid. So B says it was not valid because the sample was biased, which it was, since the customers just lived in California. Well, that's true. So it's probably going to be B, but let's just check D. And D says it wasn't valid because the male customers were all ages 25 to 40. Well, that's what they wanted to look at. That was their population to begin with. So that was okay. So it's not D. So that makes your final answer B. Thank you for joining us today, and I hope you learned something new.